Two hard doc copies of things that you need to do today from your agenda. Okay? There's 3 links in your agenda that you have to do. One of them is an echo task which you can do in echo. The other 2 are hard doc copies. Those 2 hard doc copies are sitting at Schaaf's group's table. Okay? One's titled Flame Test Lab, and the other is a concept map, a 4-bubble concept map. Okay? When I tell you, everybody needs to go get those 2 documents. Okay? In the agenda, the last part, the last bullet point, the literacy task that says indicators of chemical change, that's what the 4-bubble concept map is for. The prompt in echo will tell you exactly what you're supposed to do for that task. Okay? However, what we're starting with today is your flame test lab. So that's what we have to focus on first. And here's basically what we're looking at. Once you guys get that hard doc copy of the flame test lab, I'm going to give you 4 minutes to preview the introduction. That introduction should generate some need-to-knows, some general questions. Much of what the introduction says, we have addressed in periodic pieces, and we addressed in nuclear know-how. But it might be rusty in your head. In order for you guys to get the maximum amount of learning out of the lab today, we need to kind of revisit some of those older concepts that we saw in earlier projects. Okay? So you're going to be given 4 minutes to read that introduction, and I literally want you right on that paragraph in the introduction, I want you to write questions or circle things. What does that mean? Make notes in the margin, make notes between the lines. I don't care how you do it. That should generate some questions. Oh, you know what? I remember talking about this idea, but I don't exactly remember what it means. Okay? That's what I want you to do for 3 or 4 minutes. After that 3 or 4 minutes, we're all going to come over here. You guys are going to tell me what those questions are, and I'm going to give you a quick mini workshop readdressing those questions before we do the lab. So we got it? So that's where we are right now. Okay? When I say go, you can go get those documents. We'll count the clock as it says 107, we'll count it as 108. That means at 1:12, I will expect you to have that introduction read and questions generated, and we're all coming over here at 1:12 to address some need-to-knows in the mini workshop before the lab. Okay, here's what I need. I need you guys to come on over here and let's look at some of your questions.
I have a lot of those.
Okay, as always, we're going to do some need-to-knows here. Respect the fact that let one person talk at a time. Okay, everybody will have an opportunity to ask a question if you have a genuine question from what you just read as far as the introduction. Okay, but in order for me to hear them clearly, make sure only one person's talking. Okay? So reading that introductory paragraph about your flame test lab, what are some questions that you guys came up with? What are questions that generated? You just raise your hand and I'll call on you. Haley.
What happens if there's more or one element that burns like blue-green?
Okay? So I guess what you're saying is what happens if more than one element burns the same color? Good question. Okay, what else? Wade?
We need to be careful of getting these on us.
Okay. I guess we should say, are they dangerous to touch? Wish?
What is configuration?
Okay, what is configuration? give you guys a workshop on this stuff because a lot of this stuff we've covered already. But it, like always, if you don't use it every day, it gets rusty in your mind. So let's kind of refresh our memories to some of the concepts you guys did in your periodic pieces and your nuclear know-how projects. Okay? Today's lab really fundamentally is based on atomic structure. What an atom looks like. Okay? And in periodic pieces we started looking at atomic structure and then we started comparing the structure of different elements from the periodic table. Okay? So let's just start with a general description of what do we think atoms look like. And think back to some of the models that we've talked about in the past. Okay, we're really going to focus on the Bohr model, which the document talks about, Bohr and Rutherford model. Okay? So that leads me to a question. What are in atoms, or what are atoms made out of? What could we find in atoms, Joe?
Matter.
Okay. What is that matter made of, though? If you were going to describe what's in an atom, what would be one thing you'd say, oh, an atom has? Go ahead, Joe.
Ions.
Okay. Are atoms, do atoms have ions in them, or do atoms become ions? Shaw.
Protons.
Okay, protons. Atoms have protons in them. Where are they found? Okay, so we have the center region of an atom called a nucleus. And in that nucleus, we know we have positively charged protons. You got another one, Will?
Neutrons.
Okay, we also, in the center of that atom, have a neutral particle that we call neutrons. So the center of an atom, the nucleus, has protons and neutrons. That's stuff we learned in periodic pieces. What's the third component of an atom? Electrons. So outside of this nucleus, we have this region of space that we call the electron cloud, where these negatively charged electrons are moving around the nucleus. Okay? So that's just kind of a refresher on atomic structure. What do we think atoms look like? Okay? We have to know that to be able to answer some of your need-to-knows. Now, you didn't necessarily give them to me in a perfectly sequential order that I would teach them. So I'm going to kind of say, okay, we can address this concept first. I'm going to kind of address them out of order, but in an order where I feel is best to build one question into the next. Does that make sense? Okay. Now, the last three things are what we need to kind of concentrate on. What is configuration? Well, how does an electron orbit change with energy? How do electrons get to excited states? What does that mean? Well, you need to think about when something absorbs energy, how do you think that affects its motion? If I've got a particle, like an electron, and I supply that electron with energy, how do you think that's going to affect the electron's motion? It's going to speed it up. Kinetic theory. Okay? All matter has particles that are in motion. So atoms have particles that are in motion too. Specifically electrons. Electrons are constantly moving around the nucleus in what are called specific orbits. Okay? When you supply energy to electrons, electrons have the ability to absorb that energy like matter can absorb energy, and they become what's called excited. Okay? How much energy an electron possesses in an atom is specifically determined by how close it is to the nucleus. The closer electrons are to the nucleus, the lower their energy. The further electrons get from the nucleus, the higher their energy. How does an electron orbit change with energy changes? What are we supplying, Lexi? Was this your question?
Yeah.
What are we doing to give it that energy? In this lab, how are we giving the electrons energy? We're going to give them the energy in the form of heat from the Bunsen burner. That's going to create the electrons to an excited state. And then when they fall back to where they're supposed to be, called ground state, you're going to see colors given off that's based on the atomic structures of those different elements. And those different elements don't have the same atomic structure. That's why they burn off different colors. Does that make sense? So can we say we've answered this question and this question?
Yeah.
Here's basically an overview of what you're going to do. You're going to get wood splints. Okay? Your chemical samples are up here. You're going to wet your wood splint, get it good and saturated. You're going to dip it in the chemical, and some of the crystals of the chemical will stick to it. then you're going to run it over the Bunsen burner and record what you observe. Okay? When the stick catches on fire, understand that these things burn like yellowish. So if the stick is burning and you say, well, this chemical has a yellow flame, be sure that it's not you don't confuse the chemical color with the stick burning. You might have to redo it. Okay? Once you're done burning that chemical or the wood splint catches on fire, just stick it in there's beakers with water. Just stick it right in there and let it sit. Okay? And at the end of class, we'll let it all cool down and then we'll throw them away. Okay?
Awesome. Do you have any other cool color?
Okay, guys, listen. Just stop what you're doing right now. Give me 2 seconds of your time, and then I'm done talking. The rest of the day is yours to work. Okay? Now that you have done the flame test lab, you have to start thinking about why is that valuable for your investigation in your CSI project. Okay? I have cleared off a section of the whiteboard over here that kind of says, why are we doing this? As in, why did we do the flame test lab? I want you guys to come up with a group reason. Why did we do the flame test lab? What is the specific connection to the project right now? And each group is going to come up here and you're going to literally write your answers to how what we did today is connected specifically to the project. You got it? And then we're going to I'm going to let you guys have time to make this a living list, and then we'll kind of revisit it 4 classes over today to make sure that you're on the right track for planning your next steps to whittling your suspect list down. Does anybody have any questions? So make sure you do that today. Somebody out of your group, come up here and document what your group thinks about this activity and how it connects to the project. You got to do your chemical reactions equations task, and then you got to do that hard dot copy indicators of chemical change task. Make sure you look at the due dates for all these 3 tasks, of all these tasks for today. Okay? Make sure you know when they're due so you don't feel pressured. Do you have any questions? If you need me or Mrs. Lofthouse, come up and ask us. Don't just guess. Make sure you're doing it right. Okay? That's it. The rest of the day is yours to work.
Okay, the wrap up for today's lesson was the students were given a video of suspects in this crime scene that stole chemicals from our laboratory. The residue of those clothes were burned in a fire that the kids saw that was collected by the Van Wert Police Department. So our hope was we could connect them to the fact that different elements burn different colors. So here's some of the things that the kids have come up with as far as proving to us informally that they've made the right connections to what we want them to know from today and to the project that we're doing right now. For example, it says, by knowing what color they burned, we can compare the color to the video. By narrowing down what chemicals were burned in the video. To determine the elements that were stolen by comparing what we did today to the police flame video. So a lot of our students are making those connections, and that's what we're looking for today. Thank you.